Today we're going to look at solving this linear inequality. So the linear inequalities look intimidating when you first see them because of the fact that we have that inequality there. And it's like, how do I deal with that? You just deal with it as you would an equation. You just treat it like an equal sign temporarily and just have that mindset of this. I just need to solve for x on one side or the variable on the one side, and then we'll figure it out from there. Because what we're trying to figure out here is, for what x values does this make a true statement? So meaning, like, if I got a statement saying, x is less than 3, that means that for all the x values strictly less than 3, that will make this inequality true. That's what we're trying to figure out here. So let's just solve. I see brackets, I see parentheses, I see a lot of things happening. So within the brackets, I see that I can distribute that negative into there. And I can also distribute the 3 over here. So 3 times 3x is 9x. Minus 3 times 5 is 15. Less than 3 minus, and I'm going to not try to do too much at once, but this is going to become 6x minus 5x plus 2, because I distributed minus, so negative 5x. Negative times a negative is positive 2. Minus 4x minus 3. From here, then, I can now you could do two things. You could either distribute the negative all the way in here through everything, or make it a little bit easier on yourself. Let's combine like terms inside the bracket. Let's just take care of that. And then so I have the 6x minus 5x minus the 4x. And then I also have 2 minus 3. So I'll have 9x minus 15 less than 3. And then I'm going to clean up the brackets first before I distribute that minus sign. So inside here, 6 minus 5 is 1. 1 minus 4 is negative 3. So 6 minus 5 is 1. 1 minus 4 is negative 3x. And then we have 2 minus 3, which is negative 1. Now I can distribute this negative into here and take the opposites of that sign. So 9x minus 15 is less than 3. And this is going to become plus 3x, because this is negative times a negative 3x. So negative times a negative makes that a positive 3x. Negative times a negative makes that a positive 1. Or just flip the signs. This is what we're really doing here, because I'm distributing the negative into here. So I'm just flipping the signs if you want to think of it like that. Then we have some things to clean up here. So 9, let me change colors. 9x minus 15 is less than, I have these like terms, 3 plus 1 is 4, so I'll write this as 3x plus 4. Finally, we're starting to clean up a little bit. I'm going to subtract 3x from both sides. 9x minus 3x is 6x minus 15 less than 4. Add 15 over. I get 6x is less than 19. And last step, divide by 6. So x is less than, and that does not simplify nicely. So that's just going to be 19 over 6. So what that's saying is that all the x values less than 19 over 6. So we could say x is less than 19 over 6. So that's strictly less than that, or we could write this into interval notation. So if we're saying all the x values less than 19 over 6, and if you want to even graph this, you can. So if we're looking at 19 over 6, that would be here, 19 over 6. And I want all the x values less than that. So I want every single x value, that is less than 19 over 6. I don't want to include 19 over 6 because the inequality says strictly less than. So I want all the values strictly less than 19 over 6, so there's our graph. The interval here would be negative infinity all the way up to 19 over 6 with a parentheses. We use parentheses when we are saying strictly less than or strictly greater than. We use brackets if we are saying less than or equal to or greater than or equal to. But in this case, it's strictly less than, so we want to just use parentheses. And then even if it was greater than, less than or equal to or greater than or equal to, you wouldn't ever put a bracket on infinity, no matter what, because you can't cap infinity. So that would always be a parentheses. But like, this would be like bracket 19 over 6 to negative infinity, like that. But you'd always use a parentheses. But that's not our problem. But just wanted to talk about that a little bit. Yeah, good problem here. A lot of steps going on, a lot of room for error, that there's a lot of potential mistakes that can be made, especially with all these negative signs being thrown around. It's really easy to just drop a negative. It's really easy to just combine like terms incorrectly, accidentally, just make little mistakes like that. But if you're careful, should have been too bad.